Okay, so I want to go over with you the area of regular polygons pretty quickly. You all know the area of most of the other shapes. They're pretty straightforward, but polygons are just a little bit strange. All right, so what I'm showing you here is a hexagon. It's got 6 sides, A, B, C, D, E, F, inscribed inside of a circle. So obviously that's going to mean that all those vertices are on the circle. So there's a few parts that I just want to point out to you vocabulary-wise so that if you see them later, you know them. All right, so there is this, obviously the point in the center. You know that like AB, if we're talking about the hexagon, is called a side. If I draw this segment, think about what that is in the circle, right? I'm going from the center to a point on the circle. So that right there is going to be called, they call that the radius. Even, I know you know that it's true of a circle, but it's even called the radius of the polygon itself. And then we have this perpendicular distance, which you all know perpendicular distance is usually called like altitude or height. But since it's not going to run all the way through our figure here, right? I'm just going like from the center to the side. That perpendicular distance is called the apothem, which is a very strange word. I have no idea why they use that word, but that's what that's called. Okay, so we're going to do just this first problem. We're talking about finding the area of a regular polygon. Now, there is actually some information in just that statement that you may not realize is important. We've talked about that this year, though. A regular polygon is a polygon that has congruent sides and congruent angles. So below, I've got this pentagon. It has 5 sides, and I know that they're all going to be the same size. Now, if this said find the perimeter, that would have been super easy, right? If all of them are 10, then this perimeter would just be 50 centimeters. But they want me to find the area, and normally we think, well, they need to give me some more information for that. But really, we know all the tools we need to find all of that information. So the first thing that I think, anytime I'm talking about polygons, is that to find the area, I like to think about it as breaking it into triangles. Because I know if I can break this up, that I'm going to end up having 3, 4, 5 triangles that are all the same. I don't know if you can kind of see that visually or mentally, those 5 different triangles. So really, I just need to figure out how to find the area of one of them. So that's going to be my goal. And I know to find the area of one of them, so now I'm finding the area of a triangle. Well, the formula for the area of a triangle is 1/2 base times height. And that is assuming that base and height are perpendicular to each other by definition. Well, I've noticed here that I've got this base measurement. I know that that's 10, and I can draw this height, or what we just called the apothem in, but that doesn't really help me because I don't know how big that height is. And I can't do, even though that's a right triangle at the moment, I can't do Pythagorean theorem to figure that out because I only have one side. I can't do trig because I don't have any angles. And that's where I'm actually going to interrupt myself because I do have angles. All right, so think about this with me. We just said that we could take this and split it apart into 5 congruent triangles. So if you can see that here, I've got 5 angles right here in the middle that all should be equal to one another. Well, that's 360 total degrees. So if I divide 360 by 5, I'm going to get 72. That means each one of these angles for that big triangle is going to be 72 degrees. So if I think about my triangle here, I know that this little angle right here is then going to be 36 degrees. This is being bisected or cut into 2 equal parts. All right, so now we're kind of getting somewhere. So what I need to do then is I'm still trying to figure out what that apothem is. So I think that I can set up a trig ratio here to solve that. I have an angle measurement. As we just said, I've got this angle measurement at the top. I know the opposite side down here. The whole thing is 10, so this opposite part right here on the little triangle is just 5. And then my apothem, I don't know it, so we're going to have to solve for that. So I know if I'm thinking about trig, I have opposite, which is 5, and I have this unknown value here in the middle. That is tangent. I've got opposite over adjacent, so I can set up tangent of 36 equals, let's get that out of the way, equals 5 over x. And we can solve that out. We can cross multiply. That's x times tangent of 36 equals 5, or I can divide by tangent of 36 to get x by itself. All right, I'm going to make sure that I'm in degrees. And that's going to give me the x, or the apothem, equals 6.88. Okay, so let's zoom out then and just think about all the information that we have now. I know the height of that little triangle, and I know the base, which is that 10 centimeters. So that one triangle, I'll kind of draw this out, is going to be equal to 1/2 base, 10, times perpendicular height, 6.88. And when I work that out, I get that one triangle then is going to be 34.4 centimeters. Now, I want the area of the entire polygon. Remember, this is a pentagon, which is made up of 5 triangles. So the entire polygon, or the pentagon, is then going to be that one triangle times 5, which is going to give me 172.05 centimeters squared. So that is going to give me the area of the entire pentagon. All right, so the only reason I've included this other picture is I just kind of want to talk back through that with you again, not do a whole problem, but I just want you to think. The difference on this other picture is I've got a hexagon now, so I'm still going to break it apart into triangles, but now I have 6 triangles. So to find this top angle, I would do 360, instead of divided by 5, I'm going to divide by 6. That's going to give me that angle measure. And I could still do trig to figure out the apothem that I needed. But I want you to think about the numbers that we've used so far. So to find the area of one triangle, that was 1/2 times the base length, which is the side length, times the apothem, and I'll just call that A, times A. And then when we found that one triangle, we multiplied that by however many triangles there were, which is the same as the number of sides there are. So times the number, I guess we can call that n, right? Times n, which is the number of sides. So one of the things that you're going to see in, if you ever see this formula anywhere else, is that they condense this formula. Instead of solving it out piece by piece, they write a formula for it. And I don't care what you do. You know I hate formulas, but you all are welcome to think about this however you want to. Side times n, think about that. If you know the side length and you multiply it by the number of sides, what is that you're finding? All right, hopefully you're thinking about the perimeter. The side length times the number of sides is going to give you the perimeter. So the formula that you're going to see most often is that the area of a regular polygon is going to be equal to 1/2 times the perimeter times the apothem. All right, because at that side times n is going to give you the perimeter. So if you ever see that anywhere, I just don't want you to be surprised about what that stands for. And that's all for today. I'm sorry that it's a few minutes longer than I said, but it was only one example. Forgive me.